Hello students, welcome to Power Tutorials. So today we're going to discuss Maths Class 10 CBSE, that is NCERT board, Real Numbers chapter, and today we're going to cover Real Numbers chapter in the exercise 1, which is exercise 1.1. Okay, so first of all, I welcome to all my students to start to the new batch of 2026 year. Okay, so who are starting 26 year, who are going to attempt the 10th board exams in 2026. I'm heartily welcome to you all. So from today onwards, we are going to start all the chapters for maths as well as science, each and every topic, exercise, and even examples, previous year questions, and so on. So I will be with you till 26 board exam. So if you have any doubts in between, if we can have various types of sessions, live sessions, even shorts, and in my channel there is also a post section where you can also find MCQ questions. Okay, so let's work together. I just want everyone to be interactive, because if you have any doubts, it's better to write in the comment section so that I can check and respond to you. Then only your doubts will get clarified. Okay, so make sure if you have any doubts, kindly mention in the comment section, and let's continue with our questions. Okay. So first of all, in this real numbers, first of all, let us understand what is real numbers, and then we'll go with the chapter, because in NCERT book I can see that in the previous year classes we already studied, and then they already started with prime numbers, but I don't want my students to get confused what are real numbers. So first I will give a small example, like what are real numbers first. So what are the main, the name suggests it is a real means it exists, and we can feel it also, we can say in that way. Exists in sense we can read it, and we can also visualize wherever the number is present. So simply, real numbers contains two types, which are, so real numbers itself is divided into two, which are rational and irrational. Okay, we'll discuss about irrational later. So just understand, inside rational we have one more thing, which is called, we have integers. Okay, and we represent it as z. So integers, I will say integers are the numbers which are having minus infinity to infinity, not in decimals, just as a numbers. Okay, like example, minus 9, it is an integer, plus 9 is an integer, plus 35 is an integer. Then we have whole numbers inside it. So what are whole numbers? Whole numbers are the ones starting from 0 to infinite. It does not have negative numbers. Okay, it only has positive numbers, which starts from 0 to, not only positive, even 0 is an neutral, I can say. From 0 to infinite, which are all the numbers, those belongs to whole numbers. Just a minute. So 0 to infinity numbers are the whole numbers. Then we have inside another small subset, which are natural numbers. So what are natural numbers? Which starts from 1 to infinite. So all this combined, it belongs to rational numbers. What about rational? What is in between it has? Whichever can be written in form of p by q, consider it as rational. Which cannot be written in form of p by q, then it is called as irrational. Irrational will cover it later once the exercise 1.1 is done. Then I will discuss more on irrational. Will cover about this one. Okay, now we'll study only about rationals. Inside rational, as I told you, we have integers. Inside integers we have whole. Inside whole we have natural numbers. Okay, so every natural numbers belongs to rational, every whole numbers belong to rational, every integers belong to rational. Okay, so if you go in reverse way, not all rational numbers are not integers, all integers are not whole numbers, all whole numbers are not natural numbers. Okay, so we have different types of numbers. First one is natural numbers. If you go from smallest, so what are natural numbers? Which starts from 1 to infinite. Then we have whole numbers. Only one number is different between natural numbers and whole numbers, which is nothing but 0. So from 0 to infinite comes under whole numbers. Then we have integers. So what are integers? This starts from minus infinite to infinite. Then we have the last one, which is rational numbers. So rational numbers are the one which can be written in form of p by q numbers. So all this comes under rational. So with respect to symbols, natural numbers are written as n, whole numbers are indicated as w, integers are indicated as z, rational numbers are indicated as q. These are the symbols. Okay. So we might have studied these in the previous classes, I know, but still, as per my knowledge, I just want to revise everyone that we have these types of numbers: natural, whole, integers, and rational. So all these comes along with irrational numbers belongs to real numbers. Okay, so all this comes under real, and inside real we have two subsets, as I told you, rational and irrational. Irrational will cover after exercise 1.1 is done, but right now just consider about rational numbers. Okay. Then we have another two types of numbers called prime and composite. Okay, I know we have other types of numbers which are even and odd, and I hope everyone, okay, let's read that part as well. We have other numbers which are first odd numbers, then we have even numbers, odd numbers not divisible by 2. So odd numbers are the ones which cannot be divisible by 2. For example, 3, 7, 15, all this comes under odd numbers. Even numbers, simple, just opposite case, which are divisible by 2. So any numbers which are divisible by 2 comes under even numbers. 2, 6, 8 and so on. Okay. Then we have other numbers which are prime and composite. So what are prime numbers? Which has only one end itself as factors. So which is not divisible by any number is called prime, which is having more than 2 factors. More than 2 factors are called as composite. Okay, prime in itself, example, I can say it is 3, 13, 23. This comes under prime numbers. Composite numbers are easy, which are divisible by any prime number, like suppose 4, 6. If bigger numbers, if I want to consider, then I can say 24, 250 and so on. All these comes under composite. So we have different sets which are odd numbers not divisible by 2, like 3, 5, 7, 9, 11, 13 and so on. For even numbers which are divisible by 2, like 2, 4, 6, 8 and so on, every two table, whichever is the number, that is even number. Prime number which is having one and itself as a factors, we'll discuss about factors again. And then we have composite numbers which are having more than 2 factors. Okay, so hope you understood the revision of all these topics. Now let's go to the important topic from real numbers chapter itself, that is from NCERT point of view. The topic is every number. Okay, so this is the fundamental theorem. It states that every composite number, the number which I told you, what is composite number which is having more than 2 factors. So what it is saying means every composite number can be expressed as a product of prime numbers, and this factorization is unique apart from the order in which the prime factors occur. So this is, I can say, important, but with respect to exam point of view, theorem statement is not important, but how it is happening, that is important. Okay, so what is the fundamental theorem of arithmetic? It is stating that every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique apart from the order in which the prime factors occur. So I will give a small example. If I say consider the number as 24. if you ask what are the factors, so what is a factor? Any number by which it can be divided is called factors. So factors of 24, if I want, I can say factors are, it can be divisible by 2, it can be divisible by 3, 3 is 24, 4 6 are 24, 6 4 is 24, 12 2 is 24, and then anything else, 8 table also is there. 8 3 is 24, 12 2 is 24, and 24. So among, we are using any of these, we can divide 24. Hence the factors are 2 3 4 6 12 and 24. But we want what they have mentioned here, this is important, product of primes, not composite numbers. Okay, if you see here 4 6 8 12 24, all these 3, all these 5 are composite numbers, only 2 and 3 are the prime numbers. Okay, but here they mention product of primes, not composites. So to find how to write in prime terms of prime, what is the method is prime factorization. The method is something like this. We have to write the number 24, check for the least positive number through which it can be divided. If I say 2 table, it can be divided, so 2 12 is 24. Again check with which table, 2 table I can divide it, 2 6 are 12, again 2 3 is 6, again 3 is a prime number, so it cannot be divided, so it is 2 into 2 into 2 into 3. So now I can write 24 as 2 into 2 into 2 into 3, or I can also say this is equal to 2 cube into 3. So this is the product of prime factors of 24. So I'm repeating this topic because this is very important to find LCM, HCF and all. So what is the prime factorization method? Means factors, first write it, but they are asking that every number can be written in terms of primes, not in all the factors. So for to find the number in terms of primes, what you have to do is write the number and start from the lowest, smallest prime number through which can be divided, get the number, again check for this number through which can be divided, get the number, until you get the prime number at the ending. We have to keep on dividing. So for 24 I got it is 2 into 2 into 2 into 3, which is 2 cube into 3. So what is the theorem? It is saying that every composite number can be written or expressed in the product of prime factors, and this factorization is unique. So this 2 cube into 3 will only exist for 24. For any other composite number if you take, this will not be same, it will be different. Okay, then we have HCF and LCM. So what is a HCF? Means product of smallest power of each common prime factor in the number, whereas LCM is product of the greatest power of each prime factor involved in the number. If you notice here, there is small difference. Each common prime factor is for HCF, and for LCM it is involved in the number. So this point I'm marking in red color because this is the main topic. Common prime factor, whereas here involved prime factor, involved in the numbers. Okay, so we have various methods, but first I will tell you how to use using prime factorization method. So for example, okay, I think we have example questions. Yeah, we have example questions, so I will cover in that part. Okay, so before let's solve is the example question. Consider the number 4 power n, where n is a natural number. Check whether there is an any value of n for which the 4 power n ends with digit 0. So first of all, to find a digit 0, then something like we have a suppose 50, this is ending with 0, or 60, this is ending with 0. So every ending with 0, you can simply say it is divisible by 10. Okay, so what are the prime factors of 10? Okay, I will write it here. If I say prime factors of 10, it is 2 into 5. Okay, so for every number which is ending with 0 has to have at least 1 2 and 1 5 as a prime factor. Okay, I'll write here, for a number to end with 0, it has to have, or it should have, 2 and 5 as prime factors. Only when it is having 2 and 5 as the factors, then that number will end with 0, or else it will not end with 0. What about 4 power n? 4 power n, if you consider, what are the prime factors of 4? I can write the prime factors of 4 are factors of 4 are only 2, because it can be written in 2 power 2 whole power n, or simply 2 power 2n. So what is the number? Only a factor which is 2. So therefore it will not end with 0. You have to say at the ending point place is not enough, so I will write it here. It will not end with 0. So what I told you, if you want any number to end with 0, it should have 2 and 5 as the prime factors. For example, I will take another number and explain you. So let's consider 250 as the number. So what are the prime factors of it? Let's write it. 250. If I divide by 2, 2 ones, 2 25s, and divide by 5, 5 25s are 125. Again 5, 5 5 is 25. So here if you notice, we have 2 into 5 power cube. So we have 2 as a prime factor and 5 as a 5 factor. Hence this will is ending with 0. But for 4 power n, we don't have the 5. We should have at least 1 2 and 1 5 factor, then only the number will end with 0. Okay, let's see the second example. Find LCM and HCF. Okay, now I will explain how to find the LCM and HCF using, this is important, which method they are asking. If they ask prime factorization method, then you have to follow the procedure I am explaining here. If they didn't mention method, then we'll tell you the other two methods to solve LCM and HCF methods. Okay, so let's solve using prime factorization. What we have to do is first write 6 and 20 in terms of its prime factors. So what about 6? 6 I can write 2 into 3, that's it. So 2 into 3. What about 20? 2 tens are 20, again 10, 2 5s are 10. So it is 2 square into 5. Okay, now let's write first HCF, because HCF is easy when compared to LCM for prime factors. So HCF means, what was the definition they are saying? Product of the smallest powers of each common factor. So what is common in both? If you notice here, 2, only 2 is common. So simple, HCF is 2. You can say that I have 2 but I have 2 square. But what is the statement? Smallest power I need to consider, not the highest power. So we have two powers which are 2 and 2 square. So which is smallest between these two? 2 is the smallest. So hence HCF is 2. What about LCM? LCM statement is product of the greatest power involved in the numbers. So what are the involved? You have to write everything. So what are the involved here? We have 2, we have 3, we have 5. That's it. So what is highest of 2? Highest of 2 is 2 square. Highest of 3 only 3. Highest of 5 only 5. Hence the LCM is 4 into 3. 4 into 3 is 12. 12 5 is 60. Okay. HCF is common. LCM is not common. LCM is involved. Whichever the prime numbers are involved, you have to write it, and you have to write the highest powers. Okay. Anyway, we'll solve more questions. Let's see the another question. Find the HCF of two numbers by prime factorization method, hence find their LCM. Okay, so before that we have one property for two numbers. What is the property? Is that for two numbers, LCM into HCF is equal to product of them. So this is very important, and this will question come for at least 2 marks question in your board exam as well. LCM into HCF, always remember, for two numbers, not for 3 or 4 numbers. LCM into HCF for two numbers is equal to product of the numbers. Okay, so for this question we have to first find the HCF. So I will just write 96, 104. They have clearly mentioned prime factorization only. Okay, so I will use the prime factorization. 96, 104, I will write it here. 96, I can write it as 248 is 96, 224 is 48, 212 is 24, 26 is 12, 23 is 6. 1, 2, 3, 4, 5. 2 power 5, 2 power 5 into 3. What about 104? 252 is a 104, 226 is 52, 213 is a 26, 13, it is a prime number. So 2 cube into 13. So what is HCF? HCF I can say which is common. 2 is common. What is the least? For 2 power 5, 2 power 3. So least is 2 power 3. Hence HCF I got, which is 2 power 3, which is 8. But they're not asking only HCF. What they're asking, they're also asking to find LCM. The property what I have told you, LCM into HCF is equal to product of the two numbers. So HCF I got, which is 8 into LCM is equal to product of two numbers. What are the two numbers? 96 and 404. Okay, I'm sorry. It is 404. I did for 104. Okay, let me correct it. Four zero four. 2 table 202. Again 2 table 101. 101. Let's check. 3 table is not possible. 4 table not possible. 7 7 1 is 7. 31. So that is not possible. 7 is done. Then 11 table will not happen. 13 13 13 table. Let's check. 13 17. Okay, any number is not possible. So 101 is a prime number. So simply I can say 404 as 2 square into 101. Hence HCF now it becomes 2 square, which is 4. Okay, now it becomes 96 into 104. 4 into LCM is equal to 96 into 404. Just a 2 minutes.
Hello students, welcome to
Okay, let's continue. So here we have 4 into LCM is okay. So 4 into 101. So hence LCM becomes 101 into 96, 606 909. So 6969. So the LCM of this numbers is 9696. Okay, let's move to the next one. Find the HCF and LCM Okay, we have three numbers now. We have 6, 72 and 120. So what are the names? 6, we already know it is 2 into 3. 72, I can write it as 2 36, 2 18s, 2 9s and 3 3s. 2 cube into 3 square. 120, 2 60s, 2 30s, 2 15s and 3 5s. It is 2 cube into 3 into 5. 2 cube into 3 into 5. So first HCF. For all three, if you take common, which is common here, only 2 and 3 is the common, and we have to consider the least. So that is HCF. LCM, I will just first write all the prime factors involved. So 2, 3, 5 are involved. Now let's see the highest. Highest of 2 is 2 cube. Highest of 3 is 3 square. Highest of 5 is 1. So 2 cube is 8. 8 into 9. 8 9 is 72. 72 into 5. 5 2 is 10. 7 5 is 35. 36. So the LCM is 360 and HCF is 6. Okay. Let's start the exercise questions from now on. So exercise questions, I will not solve all the questions because I want you guys also to try. So what I will do is, if you have 3 questions, here we have 5, so I will solve 3 questions. I want 2 as a homework. Okay, if you have 4, I will solve 3. Okay, in that way I will do it. So here I will solve 1, this one and the last one. I want these two to be homework, 156 and 5005. Okay, so just try these 2 questions. I will help you how to solve other 3. I just want you to try these 2 and let me know your answers in this video and in the comment section. In the next video I'll definitely solve these 2 as well, and I will help you with the solutions. Okay, but I want you guys to try. So let's solve for 140. So what is the question? Express number 1 of prime factor. So it is easy, just 140 I will write it here. 2 table, 2 7s are 40, 14. So 2 70 is 140, 2 35 is 70, 5 7s are 35. So it is 2 square into 5 into 7 is the expression for 140. What about 3825? So 3 8 plus 3, 11, 11 plus 7. Okay, it is divisible by 3. So 3 1s are 3, 2 3 2 is 6, 22, 3 7s are 21 and 3 5s are 15. Again 3 table, the logic is if you add all the numbers and if you divisible by 3, then it is divisible by 3. So 2 plus 1 is 3, 3 plus 7, 7 plus 3 is 10, 10 plus 5 is 15. So again divisible by 3, 3 4s are 12, 3 2s are 6, 3 5s are 15. Okay, now it's 6 plus 5, 3 table not possible, so 5 I will use it. 5 8s are 40, 5 5s are 25. Again 5 1s are 5, 35, 5 7s are 35. 17 is a prime number, so I will stop it here. It is 3 square into 5 square into 17. Okay, let's solve the last one. 7 4 2 9. It is not, it is an odd number, so 2 is not possible. What about 3? 7 plus 4 is 11, 11 plus 2 13, 13 plus 9 20. Even 3 is also not possible, so 5 is not possible. So what are the prime numbers? I will write it here. We have 2 3 5 7 11 13 17 19 23 and then 29 and then 31. So mostly between here itself you will get the answer. 2 is not possible, 3 is not possible, 5 is not possible, 7. Let's check for 7. 7 1 just 7. Then 42. 7 6 is 42. Yes, 7 is also not possible. 11 definitely will not be possible. What about 13? 13 table 7 4 2 9. 13 5 is 65. 92. 13 7s, 13 8s, 13 8s, 7 3 7. 7 7. Okay, 13 7s 91. Okay, 7 is also not possible. Okay, so I think maybe 19 table it will be divisible. Okay, we have 17 as well in between. So let's check for 17. So this is the only method, there is no other go. We have to keep on trying one by one prime numbers and check whether the number is divisible or not. Okay, so just checking 13 is not done, so let's check for 17. 17 5 7 5 35 5 7 3 5 5 6 7 8. Okay. 17 fours, 7 4 28, 2 68, and then 62. 17 3 is a 51, 1 1 9. 17 sevens, 7 7 is 49, 4 7 is 7 8 9 10 11. Okay, again I'll get 7. So 17 I got it as 437. Okay, let's check for 437. 17 table 437 is possible or not. Let's see. 17 1 is 17, 17 2 is 34. Then I have 97. Okay, 97 not possible. So 17 is not divisible. Let's check for another prime number, which is 19. 19 437. 19 2 is 38. 57. 19 3 is 27. 2. Yes, 19 3 is 57. So it is 19 table. If I divide, I'll get 23. 23 also a prime number. So for 7429, I can say the numbers are 17 into 19 into 23. Okay, in this way just keep on trying for which prime number it is divisible and get for other two. I want you to solve 156 and 5005. In the next video, definitely I will tell you the solution for these two questions. Okay, let's see the next one. Second question. Find the LCM and HCF for the following pairs and verify LCM into HCF. Okay, so here we have three questions. I will solve first and third. So these two I will solve it. I want you to solve this question as a homework. Okay, so let's solve the first one, which is 26 91. So 26 I can write it as 2 into 13, and 91 5 7 7 7, so yes, 7 1 is 7, 7 3 is 21. So it is 2 into 13, and here it is 7 into 13. Okay, let's write for here as well. 336, it is a big number. Okay, let's solve it. 2 1 is 2, 2 6 is 12, 2 8 is 16, and 2 8 is 16, 2 4 is 8, 2 4 is 8, 2 2 is 4, 2 21s, 3 7s. So for 336, I will write here 1 2 3 4. 2 power 4 into 3 into 7. What about 54? 2 2 is 4, 2 7 is 14. Okay, and then 3 9 is 27, 3 3 is 9. It is 2 into 3 cube. Okay, this is for 336. This is 54. What about here? 26 and 91. So LCM of HCF of these two is 13, and LCM of these two is 2 into 7 into 13. What about here? HCF is, which is common, 2 and 3. HCF is 2 into 3. LCM 2 power 4 into 3 cube into 7 is LCM. Okay, you can solve these two numbers. So I will solve one by one. It is 13 here and 14 into 13. 14 into 13, 3 4 is 12, 1 3 1 is 3, 4 1 4 is 4, 1 1 is 1, 182. 182 is LCM here, and here LCM is HCF is 6, and this is a big number here. Okay, let's keep it aside. what they are asking, they are also asking to verify whether these two are same. So for verification, 13 into 182 I need to find, that should be equal to 26 into 91. 13 into 182 I need to find, I need to confirm it with 26 and 91. I need to prove this. This is another question. This is 1. I'm solving both at the same time, and it is 3. Okay, but you solve it only once at a time. Okay, so here it is 6 into 2 power 4 into 3 cube into 7. 6 into 2 power 4 3 cube to 7. Okay, this I need to prove it equal to 336 into 54. Okay, I need to solve these two and make sure that both should be same. Let's solve one by one. 182 into 13, 3 2s are 6, 3 8s are 24, 2 3 1s are 3, 4 5, 1 2s are 2, 1 8s are 8, 1 1s are 1, 6 6 13. So I got this answer as 2366. Now let's do for other. 26 into 91, 1 6 are 6, 1 2s are 2, 9 6 are 54, 5 9 2s are 18, 18 plus 3 is 23. So I got the same answer, 2366. Hence verified that HCF into LCM is equal to product. Okay, same I need to solve for this. 6 into 2 power 4, 2 power 4 is 16 into 9 into 7. So 6 into, okay, this is all right, it is 42 into 16 into 27. So these three I need to multiply, and then need to multiply these two to get both as same. I'll multiply one by one. 42 into 16, I'll do it first. 6 2 is 12, 1, 6 4 is 24, 25, and then this is 42. So we have 276, and then we need to multiply with other numbers, which is 27. So 7 2 is 14, 1, 7 7 is 49, 50, 7 6 is 42, 47, 2 2 is 4, 2 7 is 14, 1 2 6 is 12, 13. So this I got 4 4 11, 4 plus 4 8, 1 8 1 4 2. Just cross checking. So I got 18144. Similarly, let's cross verify for these two. 336 54, 6 4 is 24, 2 3 6 is 12, 13 14, 1 3 3 is 4 3 is 12, 13, 5 6 is 33, 5 3 is 15, 6 17 18, 1 3 5 is 15, 16. So I got 4 4 1 8 1. See, I got the same answer, which is 18144. So for any two numbers, LCM into HCF is always equal to product of the numbers. Let's solve the third question. So with this question, I will stop the video for today, and in tomorrow's video I'll continue with the fourth question. Okay, so here also this is homework, and these two I'll solve it now, and in the next video you can find these homework solutions as well. Okay, let's solve this faster because these are small numbers. 12 5 21, 12 15 21. I'll solve one by one. Okay, 12 15 21. So 12 is 2 into 2 into 4, which is 2 square. 4 into 3, 15 is easy, it is just 3 into 5. What about 21? Also it is easy, it is 3 into 7. They're asking LCM and HCF. So LCM is highest, which is, okay, let's try what are involved. 2 is involved, 3 is involved, 5 is involved, 7 is involved. Now let's see the highest. 2 square is the highest. Okay, so 2 square is 4, 4 3 is 12, 12 5 is 60, 65 is 420 is the LCM. And what about HCF? I write this common of all three. Only one, which is only 3. Okay, let's solve for third one. 8, I can write it as 2 into 2 into 2, so it is 2 cube. 9 is 3 square, and 25 is 5 square. So HCF is easy here. We don't have anything as common. So simply HCF is 1. Okay. And we have LCM. Answer is easy. It is 2 cube, 3 square, 5 square. I'll write the value here. 8. 8 into 9, 7, 8 9 is 72. 72 into 25 I need to do it. 72 into 25, 5 2 is 10 1, 5 7 is 35, 36, 2 2 is 4, and 2 7 is 14, so it becomes 0, 8, 1 8 double 0. So 1800 is the LCM value for this question. Okay, so in this way, all the questions, or not all the questions, I can say, yes, there are few homework questions, but I want you guys to solve the homework questions, and within tomorrow or day after tomorrow you can find the solution of homework questions along with the solutions of other questions in this video. Okay, so thanks for watching. In the next video we'll continue with third question, and I'll also solve the homework questions as well. And if anyone wants like one-on-one online sessions, not less like YouTube video, if you want personal training questions, so I am available for those classes as well. For daily 1 hour I am ready to help. So for that, if you want any contact details and regarding the other details, you can contact me using the mail ID I will mention here. My mail ID is powerclasses.snb@gmail.com. So you can drop a mail to this mail ID, and there you can ask me in details, and you can also mention your phone number in the mail ID. So I will contact you back and we'll discuss regarding if anyone wants any one-to-one session, or else we will also plan for the live sessions if required based upon our discussion. Okay, if you're interested, you can drop a mail to this number, to this mail ID along with your details like phone number and all, so that I will call you back. Okay, so let's meet again with the homework questions along with the solutions of starting from fourth question. Thanks for watching.